This is WFNP 88.7 Rosendale. Welcome to Curiosities of the Cosmos. I'm your host, Allyson Sheneman. Today I've brought on Meghan Luby to talk about science and education. Welcome to Curiosities of the Cosmos with Allyson Sheneman. My guest today is Meghan Luby, a junior majoring in early childhood and childhood education at SUNY New Paltz. She is an aspiring elementary school teacher, currently completing her student teaching and fieldwork in K through 6 classrooms. Meghan, thank you for coming on the show today.
Thank you so much for having me.
Of course. For our listeners, Meghan is my partner. Throughout the course of our relationship, we have had many conversations about STEM and education, inclusivity, accessibility, and so much more. And I'm very grateful to have her on the show today. So thank you again for agreeing to be a guest, and no less, the first guest on the show.
Yay!
Yay! So first, I'm going to open up the conversation about what STEM education means to you as an early childhood education major, how STEM is covered within your major, and also what your experience with STEM has been.
Yeah. I don't know where to start. I guess starting with what it means to me, and I guess what I want to incorporate into my work with students. I think that STEM can be fun, and that it should be fun. I think that it is very daunting for some kids when it's first presented, but STEM is, present in our everyday lives. By the way, if anyone doesn't know what STEM stands for, it stands for Science, Technology, Engineering, and Math. And recently, it's been changed to STEAM to incorporate the arts as well. In case anyone didn't know that. But yeah, I think that there's so much fun experimentation that can be done that I would really, really love to incorporate with my kids. And I also just want them to know how capable they are, because it is kind of, it's just such a big world of new knowledge and inspiration. And I think the coolest thing about it is that it is constantly evolving. I think that a lot of the students that I am going to teach in the future will maybe someday have jobs that don't exist right now. So it's very inspiring to me. I want it to feel approachable and accessible to everyone. And overall, I just want it to be an uplifting environment that encourages, curiosity. I just want people to explore their passions, and I want that to be accessible to everyone in the sense that I want to be a cultivator for that inspiration. So, yeah.
Totally. I think, especially remembering to define STEM is super important, because it's the kind of field where concepts and stuff like that are changing so much and all of the time. The fact that STEM isn't even really the full acronym anymore still, and that we're kind of moving away from that, is really fascinating too. I'm wondering, could you speak a little bit more about what you were talking about with what your role specifically is as an educator, and what the roles are of the community around you, the parents, their siblings, the fellow students in the classroom, on top of what your role as an educator is in order to make STEM and STEAM more fun and approachable?
Yeah, I think a really important thing, and this doesn't just apply to topics covered in STEAM, it could apply to any topic that we talk about in schools. I think that we really need to get to know our students as unique individuals, get to know their interests and their passions, and link what we work on in the classroom with those. And once they are connecting their passion to what they're working with, they see a purpose in their work. And building off of that, I think that when they find that spark and that passion, you want to help lead them there to get that, and you want to help them hold on to that passion and not lose it, because I think that, we were talking about this earlier, but I think that a lot of students that began to feel disengaged with STEM, as I personally did as I was going through public school, it's that a reason for that is because we kind of start to stray away after the younger ages from experimentation, and just kind of making science fun, science, math, STEM. And I think that we have to meet students where they are, where they feel confident in their knowledge and their skills, and help them expand on that from where they are, because I think that in order for us to reach out to all of our students, it takes a very specific it's hard to describe, but I guess we want to make sure that every student is on board and there before we add a new topic to build on. And sorry, I'm kind of all over the place.
You're good.
But to talk about what you were saying about familial and community engagement, that's so important. And I think making it fun is really important. STEM isn't everything that we do. Even I'm a huge advocate for incorporating really any subject that we're talking about in school, but specifically with STEM, I really love incorporating it into play, and especially for younger kids, because I work with younger populations from K to second grade mostly. And I absolutely love incorporating it into play because it's in everything that they do. If they are just playing with dinosaurs, you can be what does this dinosaur like to eat? And, how many dinosaurs are there? And it kind of starts from there, and you ask those kinds of questions. Same thing if a child is just kind of experimenting, with a sandbox or a box of flour, or even a water box, because I do a lot of sensory play with kids too, and there's so many scientific questions to be asked in there too, at a very early stage. What happens when I add water to this sand? How does its consistency change? Stuff like that. What happens if I were to leave this water overnight? Does this thing sink or float in the water? And I think those are all kinds of really fun questions that families and friends of young learners can incorporate into their lives. Yeah, I hope that answers that question. I'm kind of all over the place.
No, it absolutely does. I think something else to kind of add to that is just not discouraging those questions, maybe, because I feel like sometimes we forget that, especially young children, K through second and stuff like that, are experimenters. They are naturally scientists. That is a part of just kind of how they are, and to make sure that we're not discouraging them from asking those questions by making it seem like a silly thing to ask. We don't ever want to downplay when a child asks something. To be able to say, I don't know, is an important skill. It's something that I notice more and more, especially in STEM. And the farther up you get in STEM, I feel like it's harder for people to admit that they don't know something. But I tend to find, if a kid asks somebody, a trusted adult in their life, a family member, a teacher, why the sky is blue, that if that person doesn't know the answer, they might kind of just say, well, because it is, right? Or that's a dumb question. Of course it's blue. That those kinds of comments, especially as they kind of compound and they hear it from their friends, they hear it from their family, they hear it from teachers, that might really influence how somebody develops that kind of love for STEM and STEAM, especially as we kind of grow into being the people to then answer those questions. So having a small child then who's asking why the sky is blue when they have children or talk to their friends and somebody else asks them why the sky is blue, it's not that they've learned to be able to answer that question. They cannot explain it to their friends because they haven't gotten an actual answer. So they're more likely to repeat, I feel, the whole sentiment that, well, it is, just because it is, right? And I think that kind of perpetuates the cycle of discouraging scientific questioning, which seems so innate to young kids, right? It seems so natural for them to ask these questions. And it's something that rather than teach them how to ask, we almost teach them not to ask instead.
Yeah. I'm so happy that you brought that up because we were actually just talking about this in I'm currently taking a class called Teaching STEAM in the elementary school. So it's kind of just like very much on my mind. But we were talking about how crucial it is to really create safe spaces for young learners to make mistakes. And it seems cliche, but I think it really is a big discourager for a lot of students, young students, and of course as you get older, like in STEM, because for a lot of open-ended and like experimental thinkers, when they're told that there's only one answer to like a math problem, for example, that's really discouraging to them because they're very inquisitive and they might want to approach it a different way. And the truth is that, at least in my opinion, like I think there are so many different ways to answer like a math problem, for example. And it's like, will you ultimately end up at the same answer? Yes, just because that's the way that math is designed. But the ways in which you can get there are like limitless. And you'll see children use so many different brilliant techniques to solve a problem, and we should be encouraging that. And we also talked about what's called productive struggle, and there is actually kind of like a perfect balance that we want to like strive for when we're working with kids, because productive struggle is really valuable to a lot of these students. It helps support their like problem solving and like just like inquiry skills. And another thing that I was thinking about when it comes to STEM is that I really want to embrace like modeling to my students, like myself making mistakes, because it is such like a valuable trait of coming to a solution or working through like your problem solving. And I've loved doing that with my students, like in the past, where, I kind of model like what making a mistake might look like, and they can kind of facilitate, a conversation between my students where they can suggest ideas to me like, well, and they'll kind of explain their thought process to me in that way. They'll be like, well, you could do it this way. And I think that just like really opens the floor for everyone to share their unique problem-solving techniques. And I think that math should be, I keep bouncing between like all the different like STEM topics, but it's just what's coming to mind.
Yeah. Well, they're all interconnected, so.
Such a good point. They are. Yes, that's another great point. But yeah, I think we need to ask a lot more open-ended questions in STEM. I think that we need to give students the freedom and creativity to go about solving a problem however they may choose, because there's so many creative ways out there. And I think before we, reveal what the correct answer is, right? Because if you're like, I remember as a kid being in class and the teacher, there was like math class was never really an open floor for like discussion or discourse. It was just kind of like what did you do to solve this problem? Okay, yeah, that's the right answer. Like, next. And if you had any like questions or anything, it wasn't really addressed. But just because that person like found a right way to arrive at that answer, I'm sure there was so many other brilliant methods of solving that problem in the room that deserve to be discussed, because I think that students can all learn from that, and also that will empower them to, you know, have faith in their own problem solving method, because even though it wasn't that person's method, it still got them to the right answer. So yeah, more math discussion, more open-ended questions. You know, tell me more about that. Why did you choose to solve a problem this way? Stuff like that. So
Yeah, absolutely. That actually kind of perfectly like segues us into the first like segment on the show. So there's a couple different reoccurring segments, and this one is called "Should We Be More Worried About?" So I've done public science communication now for several years. I've taught at after-school centers, working with various ages of kids, and throughout my time in doing so, I've kind of mentally compiled a list of questions that people have asked me if they should be more concerned about, both that maybe we should be more concerned about, some that we absolutely should not be more concerned about. And I'm just kind of interested in your thoughts on this specifically. This has come up many times in my life, and also already kind of as a part of this conversation. So, Megan, should we be more worried about the culture of hating math in school?
Absolutely. I think we should be worried about it in the way that we should care about it. I think that, you know, when we work with, or at least like the value that I see in my work with young students, is that like these are young, brilliant minds. And as kids, I see all of their potential. No child is more or less capable of doing math than the next, or science, engineering, you know, all of the STEM subjects. And so how we approach this field, or how we approach displaying this field to them and getting them involved in it, is so crucial, because it is going to affect so many things. How they see themselves as independent thinkers, how engaged they are with the world around them. I think it is so important. And yeah, I have a quote that I think is applicable.
Of course.
Just a little reading from my class that I completed like 2 days ago. It says, it's from my textbook for this class, which I don't remember the name of right now, but I can cite it at some point. These are not my words. It says, "Now it becomes the job of every teacher of mathematics to prepare students with skills for potential careers and develop a love of math in students." Lynn Arthur Steen, a well-known mathematician and educator, stated, "As information becomes ever more quantitative and as society relies increasingly on computers and the data they produce, an illiterate citizen today is as valuable as the illiterate peasant of Gutenberg's time." And that just got me thinking, because it had me thinking, of course, I mean, our society is so reliant on technology today, kind of like what I mentioned earlier. Science is moving so quickly, and you know, a lot of these kids are going to be working in jobs that don't even exist yet, and so preparing them for that world is super important. But I think more so when comparing, you know, it kind of makes a comparison to literacy, as in like language. And I think that literacy versus STEM are taught very differently in schools. I feel that literacy tends to have a more of a focus on meeting a student where they are, whereas STEM just kind of keeps building on prior knowledge and moving and moving and moving. And I think that is what causes students to fall behind more. So absolutely more of an emphasis needs to be placed on that.
Yeah, absolutely. I think that's a great point to make. I hate to interrupt it and cut to a break, but we have to take a short break, and we will be right back. All right, so welcome back to WFNP 88.7 The Edge Rosendale. This is continuing with Curiosities of the Cosmos. I'm your host, Allyson Sheneman, and I am joined by Meghan Luby, a junior and a student of early childhood education, of early childhood and childhood education at SUNY New Paltz. We just had a wonderful conversation about all kinds of different things, from teaching STEM to kids, encouraging questions, and the culture surrounding mathematics in education. And we'll continue now with more on mathematics and science in early childhood education. So just kind of picking up from where we just were, how have you seen the culture surrounding hating math in school play out in your experiences with field work and your more hands-on experiences in the classroom? Have you had moments where you've heard students making comments about this? Is it kind of a general sense of just kind of the atmosphere surrounding it? I feel as though, at least while I was in elementary, middle, and high school, prior to starting out college, and even kind of somewhat now into university, that there's just kind of this sense that math is something people can't understand, and perhaps that's at least in part based on that feeling that it's supposed to be building off of itself, and so if you've missed a step, you miss every step after that. Mm-hmm. But I feel often people, when I tell them that I do astrophysics or astronomy or physics or biology, really anything in STEM, when I tell them about the math classes that I've taken, or when they just kind of ask me what I do, the first response I tend to get is, oh, well, that's for smart people. I can't do that.
Yeah.
And I don't think that that's because they can't find the wonder that I find in the stars. I think everybody knows that they can do that because they look at the night sky and they go, wow, that's beautiful, right? Mm-hmm. So I feel the thing that holds them back from thinking that that's something that they're capable of really stems from that specifically math education and the culture around hating math, and how either they felt it was unapproachable or just kind of at some point, again, fell behind and weren't able to pick back up. Is that something that you've seen in your students, heard in conversations with teachers, that kind of thing?
Yeah. I agree so strongly with everything you just said. I have absolutely seen it develop in my students in the early stages. I have reflected on my own educational experience in the public school system, and I know that I've also experienced it as a student, which it has inspired a lot of what I want to do with my students. Yesterday in my class, we were looking at, I guess, an early, algebraic idea. And essentially, I remember exactly what it was. It was 4 plus 8 equals blank plus 5. And we were talking about how students may answer this question and why. And then we started talking about what prior knowledge does a student need to answer this question? And it's so much more than meets the eye. So much is scaffolded into every single mathematical question.
Absolutely.
And so I've seen it with my students even at a young age where last semester I was in a kindergarten class, and it was so amazing and so fulfilling. And when I first got there, the students were working on the concept of, first counting, and then the concept of like less than, greater than, and then, they started to kind of move along into addition. And the students that I noticed were really struggling with addition were absolutely brilliant students, but were simply either like absent from school, or maybe had been pulled from class, or maybe were in class and were just struggling a bit with the foundational concept of cardinality, like assigning a value to each number to be able to count, or the concept of less or more, because you have to know that in order to move on to addition. And I see these students fall behind, and they then receive, a message from their teacher when their teacher gets frustrated with them that, I'm not good enough. I'm not doing as well as the person next to me. And I don't really understand why. And it's heartbreaking to watch. And as much as, in that situation, it's hard because we want to meet students where we are, and like that's really a huge goal. But at the same time, teachers often do have like deadlines to meet in terms of like marking their students' progress on a particular thing. So if it's a matter of getting like 60% of the class on board with addition and 40% of them aren't, then they're not going to go back and talk with the 40% before moving on, because the majority of them are there. And that 40% is still really significant. So I've noticed that. I've also noticed it in my own schooling experience. I think especially, in the younger grades, I really had a love for STEM, especially I remember doing a ton of like really awesome experiments, and like science and math were fun. And then I think, and that's because we try to work with students like, we try to use really open-minded practices while they're working on those foundational skills. And then when they kind of advance as they're getting older, moving into middle, high school, there is no more experimentation. It is a lot of just kind of applying foundational skills to become more and more advanced. And for that 40% of kids, which is actually getting larger and larger, that isn't an actual statistic. It was just a hypothetical scenario. Right. But metaphorically speaking, like that 40% of kids that are falling behind is increasing more and more due to a lot of just like socioeconomic issues in our world, especially in America. And I think we'll see this problem more and more. I think, I think a lot of students become discouraged from STEM because they are just not, they haven't mastered those foundational skills, and they're so capable of doing it. They just need a little extra time and a little extra something different, because everyone learns a different way. And I think that is another thing. I think we need less like uniformity, because STEM is complex. Everyone's a complex learner. And if we apply that philosophy to every other discipline, like, language or social studies, like why is STEM so different, So
yeah, absolutely. I think that brings up a lot of different points. I think some of it starts to kind of touch on what it means for students who learn differently, not only just in terms of whether you're a visual learner or a tactile learner and those kinds of like learning styles, but also perhaps like learning disabilities and being able to really address the needs of neurodivergent students and how a student who is neurodivergent might relate differently to STEM, but still be able to learn all of that information. And since there are so many ways of teaching it, being able to really hit for each of the different kind of target audiences, that our target audience isn't this cookie cutter student, that there's a lot of different ways to learn. And I think something else that you started hinting at is the socioeconomic disadvantages and how that might change a student's ability to progress through a field that's structured in such a scaffolded way.
Yeah.
And so when a student has to miss more class or doesn't have the funds to get a tutor or something like that, what that means for their like future really, and that kind of thing can start as early as and as young as kindergarten and early elementary school, and be the kind of disadvantage that kind of follows them through the rest of their lives really, to be able to not have gained those skills earlier on. Is there anything you'd like to add to that thought?
I absolutely agree with everything that you said. Yeah, it's so and you know, this could be like a whole separate conversation, because there is so much to address in terms of socioeconomic issues involved in our school system, but I absolutely see it, just for the purposes of this conversation, I absolutely see it impact students in STEM, and I think that there is a lot to be said about how that is affecting our misrepresentation in STEM, like professionally. So,
absolutely, yeah, and I think that a lot of that too. I don't know if you share this experience, but as a woman entering the field, I feel that there are always more eyes and more judgment on me, and I also feel as though the messages that I heard and received when I was really little about who is good at STEM and what they look like, that really like stays with you, and it's a voice in the back of your head that like haunts you. And so in every class that you take, every kind of like decision that you make, I guess, to stay in the field, because I think STEM is all about staying despite how hard it is.
Oh, I like that.
And so, at least in my experience,
productive
it's been
struggle.
Like, knowing that, that productive struggle, exactly. Knowing that it's hard, but feeling like it's worth it, right? And I feel like at each of those stages, there's this like extra voice, this like in the back of your head, and this extra kind of weight to carry when you have those experiences of coming from a socioeconomically disadvantaged background, for people of color, for women, for any really underrepresented group within the sciences. I think it's especially hard when you have that kind of like, not only the disadvantages that actually come with being a part of that group outside of STEM, but also then that kind of added like weight to carry around, if that makes any sense.
Absolutely.
Yeah. So that was a pretty heavy conversation, a pretty heavy topic, and we're going to now switch gears a little bit into a little bit more lighthearted of a conversation into our next segment, kind of give some space to breathe again. So we have another segment coming up. This segment is called Curiosity Corner. So I'm going to, thank you. So I'm going to tell you some fun facts. I'm going to give you 3 fun facts that I handpicked specifically for you.
I'm so scared.
They're going to be awesome. And you get to rate them. So please be honest in your rating. It's okay for them to be a 0. I won't feel hurt. And so you're going to rate them on a scale of 0 to 10, where 0 is something that's not fun. You've already heard it before, not interested. And 10 means you're going to think about it every day for the rest of your life.
Right. Okay.
Yeah, it's going to haunt you,
Okay.
but in maybe a good way.
Okay.
Okay. So are you feeling ready?
Ready as I'll ever be. Let's do it.
Yeah. So our first fun fact is over half of the bones in your body are in your hands and your feet.
Oh, God.
Any initial thoughts?
Can you say that again?
Yes, absolutely. Half of the bones in your body
Are in your hands and your feet.
are in your hands and your feet. Yeah, including like your ankles and wrists.
That makes me incredibly uncomfortable. That makes me feel like we should be walking on all fours, like constantly. Like if there's that much, like
Believe it or not, evolutionarily, that's probably where that came from. Yeah, some follow-ups to that is that it is 51.5%, or roughly half, of your bones are in your hands, wrists, feet, and ankles. Though, and this might make you more uncomfortable, if you are pregnant, if the person is pregnant, then most of the bones in their body are actually in their uterus because babies have more bones than adults do.
Wow.
Yeah.
Okay, well, that I like that part of the fact because
I'm surprised because that one makes me more uncomfortable.
Oh. That just makes me feel like women are so powerful.
Oh, so true.
But if you were to ask me to rate the
0
hands
to
and the
10.
feet fact, I am
0 to
so
10.
sorry I'm rating it a 0 because
Wow. Okay.
I don't want to think about my feet ever. And now I'm going to think about them.
All right. We're off to a strong start. All right. Next fun fact. The next two are a lot less uncomfortable,
Okay.
I think, because they don't have anything to do with your body.
Oh,
So,
okay.
Yeah, you're welcome. This one always blows my mind, and I might have to say this a couple different ways because I've never found the right way to say this that it makes sense the first try. But when you get it, it's going to be awesome. There are more molecules of water in a cup of water than there are cups of water in all of Earth's oceans.
What? Ooh, that's a good fact.
That's good, right?
I like that one.
It helps give a sense of like scale,
Wow.
right? To how small things like molecules are.
Lots of molecules.
Lots of molecules.
That's pretty cool.
You like that one?
Yeah. Yeah.
Better than the feet?
Yeah. I'm gonna go on a limb here and rate that one a 10.
Wow. So you realize that means you're going to think about it every day for the rest of your life?
I think I will in like a good way. I think it will
Okay.
want me to stay more hydrated. Like I'll be like, I'm drinking so many good molecules for my body right now. I'm literally like, I'm like powering up.
That's awesome.
Yeah.
Yeah, I like that. Stay hydrated.
Yeah.
You're drinking so many molecules. They're so important. There's so many of them. Are you ready for the last fun fact?
I was born ready, actually.
Born ready. All right. This one I think you're going to like the most.
Okay.
It's actually, and this was not planned, completely in theme with what you're wearing right now.
Aww.
Because I know everything about you.
I love strawberries.
You do love strawberries, and
about
this
strawberries?
is actually about strawberries.
Oh, yes.
So, fun fact, bananas are technically berries, but strawberries are not.
Oh. I feel like this is tomato a vegetable conversation. I mean, is tomato a fruit conversation? God.
So, berries are technically defined by being a fleshy fruit surrounding seeds. So we've talked before about how the only fruit that has, another fun fact, I guess, an extra one, the only fruit that has its seeds on the outside is a strawberry. And so that makes it technically not a berry because the seeds are on the outside, whereas a berry has to be the fleshy fruit outside of the seeds inside.
So
Because you're so smart and that
Okay.
has scientific reasoning behind it, I'm going to give you half of the points.
Okay.
I'm rating it a 5, and I'm taking away 5 points
That's a failing grade.
because I don't like it.
Okay, understood.
But I like the scientific reasoning. I just, a strawberry is a berry in my brain.
Except
It has seeds on the outside.
it has seeds on the outside, so it's
I
not.
know.
Yeah,
It's okay.
unfortunate.
Yeah.
Anyway, so those were our fun facts for today. I hope you learned something new.
I did.
Thank you. I was talking to the listeners.
Oh,
I'm kidding. I also hope that you learned something new.
did.
And I hope that for the fun facts that are going to haunt you and stay with you forever, that you like them. And for the other ones, you can just move on with your life and just know that it's true. Because science is true whether you like it or not.
Oh.
Oh, okay. So, kind of, I guess, throwing out another little conversation before we have to take our next break, since we have a little bit of extra time here. Do you have anything you want to say about, like, your specific journey with STEM, how, like, STEM has fit into your life, and I guess kind of, like, what has encouraged you to care so much about teaching STEM to kids, and also what maybe has drawn you away from pursuing STEM yourself, since you talked about having such a love for STEM in your childhood and in that time where it becomes where it comes so naturally to kids to be interested in STEM, and what kind of has drawn you in a different direction.
I love that question. That's a cool question. Well,
Yeah.
as I previously mentioned, I had a really. I lost my train of thought.
That's all right. That's all right. It totally happens. So, just talking about,
Just
like,
my personal experience.
your experience with STEM, what draws you towards it in, like, working with young kids, towards doing it better, and also what draws you towards, or what's maybe drawn you away from pursuing it yourself.
Yeah. Well, when I'm gonna sneeze. I'm so sorry.
It's okay. You can sneeze. Bless you. We're all people here. We've all got half of our
It's a
bones in our
scientific
hands and
bodily
our
function.
feet.
We're talking about sound.
All people.
So, well, fun fact, I you know this about me. I love animals, and when I was younger, for a while, I really wanted to be a veterinarian. I have always loved STEM, like, from a young age. I did, and I think it always kind of came very naturally to me because I tend to be a bit more of a type A thinker. Not that type B thinkers aren't welcome in STEM, because you are, but for me it was just, not that there's two ways of thinking, but I'm just a little, like, you know,
The teacher in you,
the way that my
making
brain
you
is.
explain.
Yeah.
That there's so many different approaches to
Yeah.
education and learning. Yeah, of course.
And so me and Sam, we were rocking in, like, elementary school. And then in middle school, I moved along to my school had, like, an advanced track where you could take, like, I was taking, like, classes that were for, like, grades ahead of me. Like, I was taking, like, in 6th grade, I took, like, 8th grade algebra.
Yeah.
And I did, like, earth science. And I don't know if any New York listeners can relate, because Ally's not from New York, but every year when you get up to those older grades, you have to take a New York State Regents exam. And I had a positive experience with my first earth science and algebra ones, but I remember feeling less, even though I, really excelled in those classes, I remember feeling way less excited to delve into any of those topics. It began to produce a lot of anxiety for me.
And as I moved along into high school and kept going on this honors track, that's when things started to get really bad for me. I think that, building off of like the scaffolding, right?
Yeah.
I think that because I was on those honors tracks, they were like, you're just so smart. We don't have to cover this thing, this thing, this thing, and this thing.
Right. This kind of like assumed knowledge.
Yeah. And the big news, the hot take was that I didn't know it.
Right.
Because we didn't learn it.
Right.
But I just kept moving along. This track of now you're going to do trigonometry, and now you're going to do geometry, and then you're going to do pre-calculus, and then calculus, and statistics, and this and this and this. And I just wasn't there.
Yeah.
And I had a lot of teachers in high school that really made me fall out of love with math, and I started to identify as someone who wasn't good at math, didn't like math, because at that point, when I always thought like, I was good at it when I was younger, but I guess that doesn't really count because everyone can do like that stuff. Like now I'm in a group of people and we're doing like the real, like serious math, and everyone else around me is doing really well and I'm not.
Right. Meanwhile, everybody's missed a step or so along the way. Right?
Yeah. And I, and it just goes to show how insanely crucial it is to have teachers that are sensitive to this kind of thing and really recognize potential and encourage, inspiration in their students, because I just had some really I just had teachers that didn't like kids even, which should be just like the first,
bare minimum,
the first thing that should lead you into the profession.
Yeah,
and so
absolutely.
they, especially when I got a little bit more advanced, I kind of found that a lot of those teachers loved their subject but not teaching it.
Interesting. Yeah.
And so I would be like, can we go back and explain this, because I don't get it? And they would say, well, I already taught that. And I would say, I know you taught it, but I didn't learn it. And so I don't know how to move on from here. And that type of discourse was just unwelcome in that classroom environment. And you were kind of like looked down upon for asking those kinds of questions, when meanwhile, I feel like that should be like the first thing that teachers are like prompting from students. And so I really fell out of love with it. I discontinued the honors track. I just kind of stopped taking those classes after like, I kept up with it in like all of the like English and humanity, like liberal arts fields, but I discontinued science and math, like honors track, I guess you could say. I don't know.
Yeah.
And I think that's really sad. I think that my high school just didn't really create like safe spaces in those kind of classrooms. And even, I remember like good friends that I had that stayed with it. They had not fostered like a love for what they were doing. They just like learned how to survive and stay afloat.
Absolutely.
And that's not fun. That's not fun for anyone.
Yeah.
Why would you want to do that?
Totally. And I think sort of kind of going back to what we were talking about with the culture of hating math, I think it does kind of weed out people who would be good at math otherwise, who might be able to contribute positively to the culture of mathematics itself and of STEM itself. Mm-hmm. Because I do think that there's a certain level at which you get into STEM and it becomes kind of, not everybody, certainly, and I don't even want to say the majority of people, but just some very vocal few, become very like snobbish about it almost.
Yeah.
Where it becomes kind of like gatekept and like, I don't know, almost elitist in some ways. And I feel like certainly there are some teachers where that is still kind of the sentiment. And I feel my experiences in middle and high school, shout out to Mr. Risley and Mr. Boggs, they were the real ones, really fostered my love of natural sciences in a way that I didn't know was possible. I really only wanted to pursue astronomy. And the reason that I'm double majoring and I'm doing biology also is really because of the foundations that they laid for me so early into like middle and high school. And I feel like part of what inspired me so much about their teaching that made me want to bring them up specifically is that the teaching and the science were so deeply interconnected. And I feel like something that I'm noticing now as I get into science more and as I get into science communication and working with the public trying to communicate science, that there's kind of a point in the field, and I think it happens in undergrad within STEM, where people kind of branch into either public science communication and working with the public in science and doing planetarium shows, doing museums, doing things like that, and a branch that goes off into more of like research or something along those lines. And I think that something that I've noticed, and again, it's certainly not with everybody, and I don't even want to say the majority of people, but it's a sentiment that I've noticed repeated, is that people who go into research and stuff like that tend to kind of act, I guess, as though the communication part of it doesn't exist. When no matter what you do, whether you're doing research, whether you're doing museums, whether you're doing really any job in STEM, whether you're teaching STEM at a school, you're still going to be, in some ways, communicating your work, trying to get people interested, and trying to explain it to people, trying to teach it to people. You have to teach it to somebody enough to get a grant for it. You have to teach it to somebody enough that they're interested in it and ask their own questions at a show or something like that. And if you're an elementary school, middle school, high school teacher, you have to teach it from scratch, right? But I think that some people tend to kind of, I guess, pretend like you can do science without ever having to do the teaching part. And so it kind of becomes like it's almost two separate things, if that makes any sense.
Yeah, I think that's definitely the perspective that this one teacher that I'm thinking about had. I was, how old was I? I think I was like 15. It was like my freshman year of high school. And I had a geometry class. It was my first time taking geometry. It was honors geometry, so I was expected to know everything on geometry, even though I had never taken geometry.
Naturally.
And I remember what he said to me. I asked, so I'm looking at like how you solve this problem, and I didn't understand this one step, and I never forgot. He said to me, well, if you don't know this by now, you're never going to know it. And I was like, oh, all right. Well, I guess you just kind of decided my fate for me right there.
Wow.
And so,
yeah, that's powerful.
Yeah. And, so I thought about that, and that was the kind of environment that was in that class, which, I'm very sensitive to the environment around me. So I guess just kind of for my own, like, self-preservation, I just kind of, like, I turned him into, like, the, what is it, like, the Charlie Brown, like, wah, 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 and I just kind of, like, zoned out.
You tune him out. Yeah, totally.
And, but, I think that really stuck with me. And
it's a damaging thing to hear.
Yeah, and I thought about that, and I think that led to, a lot of my own struggle, but it also became the reason why I love doing what I do, and like what led me to do what I do, because I was so like angry about it for so long that I turned that anger into passion. And I would always think like, oh God, like if I were him, I would have done this and this and this and this and this. And when I was trying to figure out what I wanted to study in school and like do with my life, I was like, well, I have a lot of ideas about this. Like, what if I just did this myself, but like did it better?
That's awesome.
And like, not that I am perfect by any means, but I just want to be a presence in kids' lives that is thinking about the messages they're receiving, because kids are sponges. They're so impressionable, and the messages we communicate to them matter. And it matters how we talk about ourselves too, about how we model things.
Yeah.
Like I was saying earlier, like when we model our own mistakes and we still talk positively to ourselves, and we work through it, and we kind of welcome mistakes as like an invitation to, it's kind of exciting. It's like, oh, well, this is something we can think about more and figure out. So yeah, that's basically what led me to do what I want to do.
Awesome. Yeah, with that, we're going to take another short break, but stay tuned because we'll be right back. Welcome back to WFNP 88.7 The Edge Rosendale. This is continuing with Curiosities of the Cosmos. I'm your host, Allyson Sheneman, and I am joined by Meghan Luby, a junior and student of early childhood and childhood education at SUNY New Paltz. We were just talking about turning the negatives, turning your mistakes, and turning your ideas into passion. And we're going to continue now with our last segment, just for our remaining few minutes here. So for our last few minutes, to end every episode, I asked the guest to bring in their favorite question that they've ever been asked. So Meghan, what is your favorite question?
I think that is a very difficult question to answer because I've probably been asked a lot of questions in my life.
And they're all good questions.
Yeah.
Yeah.
Yeah. I think.
So what's a good one?
Yeah. I think in light of what we're talking about, working with kids, I'm thinking about my experiences in the classroom, and I'm thinking about questions like kids have asked me.
Totally.
And my favorite one that comes to mind was asked to me by a kindergarten student. And the kids always love to know, like, what is the next thing that we're doing, because their brains like move so quickly, and right. I love it because they're excited and they want to know what we're doing next.
Yeah, totally.
And so I said, in about 2 minutes, we're going to pack up and go to recess.
Right.
And he was like, how long is 2 minutes?
Wow.
And I was like, I love that question because it's so like pure and beautiful. Like he's just like enjoying his life as a 5-year-old child. And for all he knows, he could be in the classroom having fun because at the time, they were just like doing like free play.
Yeah.
And he could be in the classroom like having fun for however long, and eventually he's just gonna make his way to recess, and like everything's gonna be okay. And like, I don't know, it reminds me of a simpler time. I think
maybe before you had to know what 2 minutes really was.
Yeah, because like we're out here adulting now. Like when I think of minutes, I'm like, oh, like I'm thinking like, like how many minutes till I have to make it to this place, or how many minutes till this assignment is due, and it's so stressful, and how many minutes do I have to like merge onto this road, and
scary.
Like, I don't know. It was just such a pure question.
That's beautiful.
So yeah.
Yeah, a simpler time, as you said.
Yeah.
All right. Well, that is actually all the time we had for today. So thank you again, Meghan, for coming on the show. And of course, thank you for listening. This has been your host, Allyson Sheneman, and my guest,
Meghan,
on Curiosities of the Cosmos. Tune in next week for another episode.